Hi guys, so today we're going to be doing u-substitution, which is basically when an integral is ugly and you just rename part of it. So first, let's talk about what even is u-sub. Well, u-sub is basically, let's say you have this integral right here. So integral f of g of x times g prime of x dx. You're going to let u equal g of x. And if this looks confusing, I know, I understand, but just remember these rules, okay? So, pick the inside, take the derivative, slap a du on it, rewrite in terms of u, integrate, plug back in. Now that sounds like gibberish, but here are the golden rules, okay? And then, don't worry, we'll go through some more examples. Okay? So, choose the most inside thing. Okay, you'll see that later. Choose what makes dx disappear nicely, and if something gets worse after choosing u, you're choosing the wrong u. Okay, so let's start with our first example. Integral 2x times x squared plus 1 cubed dx. Okay, well, the most inside is x squared plus 1. And if you notice, if we take the derivative of this, we get 2x, which is the outside. But let's just work this out slowly. So let's say we're going to let u equal the most inside, which is x squared plus 1. So du is going to be 2x, right? 2x dx. That's important. Now, we have a dx here, so we're going to solve for this dx over here. So this is going to be du over 2x equals dx. Okay? Now, what we're going to do, we're going to plug it back in. So, what does this become? Well, let me write this in green. So this becomes the integral of 2x u, right? Because we said u is x squared plus 1 cubed, and the reason we can do this is because we transformed this dx into a du. So now we're just plugging this in for dx. du over 2x. Okay? So now we just cancel these out. So now we get integral u cubed du. And now, since everything is in u and we have du, we can just integrate normally. So this would be u to the fourth over 4, right, plus c. Never forget that constant of integration. And now we just plug in this u back right into here because we need to, they gave us x. We can't just give them a u. Okay? So we're going to put it back into x. So this would be x squared plus 1 over 4, or to the fourth over 4, and then plus c. Alright, so first try, guys, and you already did such a good job. Alright, so let's move on to the next question. Okay, cosine 3x times 3dx. Now, how do we even do this? Well, what's the most inside function? Well, the most inside function is 3x, right? Okay? And if you don't know, just you can test them out, but know if somehow you made something worse, you're doing something wrong, okay? So I'm gonna use blue. So this is like a kind of like a scratch work. So u equals 3x, the most inside thing, in quotes, thing. Du is 3 dx. Okay. Solve for dx. So du over 3 equals dx. So now let's integrate this. So it'd be cosine u, right? Cosine u. I'm plugging this in. Cosine u times 3, and instead of d of x, we said d of x was du over 3 times du over 3. Now this is really easy. We cancel out these 3's. So now we're left with integral cosine u du. And now we know that this is sine u, right? The integral of cosine is sine u plus c. And now all that's left to do is plug in back this u right here. So we get sine of 3x plus c. So you guys see that it isn't so hard once you get the hang of it. All this requires is just practice. But we're done. Let's move on to the next question. Example 3. Okay. Integral 1 over x times ln x to the fourth. Okay. Well, what do you guys think the most inside function is? Okay. It's going to be ln x, right? So this looks hard, but it's actually a legal level of easy once you see it. So we say u equals ln x du is 1 over x, right? Especially for u sub and integrals in general, you're going to need to know have a really good knowledge of common derivatives and integration questions. So you need to know the integral of sine, cosine, tan, arctan, all of that, and vice versa with derivatives. So anyway, let's just keep going. So let's solve for dx. So this would be x du equals dx, right? And now we have our u, du, and dx. So now let's put this into our function. But like I was saying before, it's really important that you guys memorize those common integrals and derivatives, because your life is going to be so much easier if you do. You get them out of the way now, because if you memorize them now, it's going to stick for the rest of your calc career. And these questions are going to show up on your AP exam. So anyway, so 1 over x, let's plug in u. So it'd be u to the 4th. And we said dx was x du times x du. Well, these x's cancel. Do you see how I know I'm doing this right? Because my integral is becoming simpler, right? Nothing's getting expanded, nothing's getting harder, okay? So u to the 4th du. So now I get u to the 5th over 5 plus c, and I plug this u back in. So now I get ln x to the 5th over 5 plus c, and there's my answer. Alright, great. Now, example 4. So most people look at this and start crying, but no, trust me, it's not as hard as it looks. What's the most inside function? X squared. So, u equals x squared, right? It's easy. Once you start seeing what the u is, you can kind of see where the problem is going to go, because you can see du is going to be 2x, and we have this x right here, so the x's are eventually going to cancel. If you don't see that yet, no worries. 2x dx. I'll show you guys later, right? So 2 over 2x equals dx. So I'm solving for dx. Now I have u, du, dx. Now let's solve our integral. So x cosine of u, and then dx. I'm going to substitute du over 2x for that. Now this is where a lot of people get a mistake, okay? So this x goes away, right? This x cancels. So now I have cosine u du over 2. Now, in the other questions, we just had a du, a du. Now we have a du over 2. Well, you guys can agree with me that this is the same thing as, right? Cosine u times 1/2 times du. Well, since this 1/2 is a constant, we can just pull this out. So now we have 1/2 integral cosine u du, and we can proceed as normal. So the most common mistake is that people forget to adjust for that u-substitution, and they don't put out this 1/2 in the front. So eventually this would become 1/2 sine u plus c, right? And I plug in back my u, so this would be 1/2 sine x squared plus c. And that's my answer. So again, the most missed question are these, because people forget to adjust for the u-substitution and they don't pull out this 1/2 constant. Alright, good job guys. Next question. Okay. So, if you guys haven't noticed, the ones we've been doing have been indefinite integrals, so that means there have been no bounds. This is a definite integral, right? We have bounds. Now, this is like the final boss of u-substitution, okay? So, what's the most inside function? It's the same steps, but we have to be a little bit more careful. Well, the most inside function is this, x squared plus 4. So u equals x squared plus 4. Du equals 2x dx. So that means dx is 2x. Du over 2x. Boom. Okay. Now, the thing with definite integrals, you're going to have to change the bounds. So now this is the hard part. about definite integrals compared to indefinite. So when you switch from x to u, right, we switch from x to u, you're literally changing the entire language of the integral. So your old bounds, which were in x, doesn't make sense anymore, okay? So you can't use x bounds in a u integral. It's just wrong. So if you don't change the bounds, then you're basically integrating from x equals 0 to x equals 2, but the inside function is going to be in terms of u, and that doesn't make any sense. So here's the big secret, and I'll show you both ways of how to do this. If you change the bounds, you never need to plug back into x. So what does that even mean? Well, look at this question, right? We had 1/2 sine u plus c. We put this u, we put it back into x squared. If we change the bounds, we don't have to do that. Okay, this obviously doesn't apply to indefinite because there are no bounds, but if you don't change the bounds, then you must plug back u to x at the end. Okay? So in my opinion, changing the bounds makes it a little bit easier, but whatever way makes it more easy for you to understand, then go with that. Okay. So, how do we change the bounds? Well, since our u is x squared plus 4, we want to change the bounds in terms of u. So our new bounds are going to become, let me use orange. So x equals 0. We're just going to plug in 0 to this equation right here. So this would be 4, right? 0 squared plus 4 is 4, so u equals 4. And then x equals 2. We plug it into this equation, that same equation. 2 squared plus 4 is 8. So those are our new bounds. So let's do this. 4 to 8 of x u to the 7th times du over 2x. It's the same steps. Now cancel. Cancel. Okay, so now we have u to the 7th times du over 2. So now 8 to the 4th u to the 7th du. And we're going to pull out that 1/2, right, like we did in the last question. So now we have this. So now we have 1/2, and then integral of u to the 7th is just u to the 8 over 8. And then from 4 to 8. Boom. And now we don't have to plug anything back into x, okay? So let me make this a little bit easier. I'm going to take out this 1/8, so it'll be 1/16 u to the 8th, 8 to 4. So this would eventually equal 16 using our indefinite integral rules. 8 to the 8th minus 4 to the 8th. And this is our answer. I don't want to simplify this all down, but this is our answer. So we never needed to put this u back in terms of x. Why? Because we changed our bounds from their original x values to their u values. So now what happens if you don't change that? You can do it either way, but let's just try it. So integral is 0 to 2 dx over 5x plus 4. The most inner function is this, right? There isn't anything special, right? U equals 5x plus 4. Du equals 5 dx. So that means dx equals du over 5. Okay, now, oops. I didn't write that in blue. Okay, it's fine. Okay, so 0 to 1 over u, and we said dx was du over 5. I'm going to pull out this 1/5 constant. So now I have 1 over u times du. So now let's integrate. So the integral of 1 over u is just ln u. But now let's put this u back in terms of x. So this would actually be 1/5 ln 5x plus 4. And then we put in our bounds 0 to 2. So we didn't change the bounds. So that's why we had to put this u back in terms of x. So let's evaluate. This would be 1/5 ln of put in the top. 5 times 2 is 10 plus 4 is 14. Minus ln of the bottom, so 0. 0 times 5 is 0 plus 4 is 4. 4. And boom, this is our answer. Or we can simplify it using our log rules. So it would be ln of 14 over 4. Boom. And that's our answer. No plus c because this is a definite integral. Alright, so thank you guys so much for watching. The questions we went over are pretty much all the types you'll see on the AP exams. The definite integrals are probably going to be one of the hardest. I'd say make sure you change the bounds. That's probably one of the trickiest things. Change the bounds because it makes things a lot easier because you don't have to put things back into x. Also, you make sure to pull out the constants, right? So right here, we pulled out this 1/2. A lot of people miss that. So, again, thank you guys so much for watching. If you have any questions, please make sure to put them in the comments. This is our second video in our integration series, so next time we'll be going over applications of integrals. So that's more about word problems, revolutions, stuff like that. If you have any questions or anything you'd like to see, make sure to let me know. And thank you guys so much for watching, and I'll see you in the next one.